This video, you're going to get to try your hand at solving a problem using the v squared equation. And that's the common name for this because there are two v squared terms in it. So for this equation, imagine a baseball player throws a ball up in the air going 10 meters per second. How high is it when its speed is slowed all the way down to 6 meters per second? And you can assume that gravity is negative 10 meters per second squared, and then try to figure out what is the change in x. So take a second, pause the video, and then we'll go through it together. Just like any other problem, the first step here is defining our variables. Velocity, and that's velocity final. If it doesn't say anything, it means final, is 6 meters per second. That leaves us velocity original at 10 meters per second. Then acceleration, we're using the negative 10 meters per second squared term. Now this isn't totally accurate. It's off by a little bit. But for one or two significant figures of accuracy, it's kind of close enough. And it'll make a lot of our calculations a lot easier. And then x. We don't know what x is, so that's a question mark. We're trying to find it. So now we plug in. V squared is 6 meters per second. Quantity squared equals 10 meters per second. Quantity squared plus 2 times negative 10 meters per second squared times x. So now we have to do the math. This is 36 meters squared per second squared equals 100 meters squared per second squared plus negative 20 meters per second squared times x. So now we can do some subtraction. Subtracting 100 meters squared per second squared from both sides, we have negative 64 meters squared per second squared equals negative 20 meters per second squared times x. So now we divide by negative 20 meters per second squared. Negative 64 over negative 20 equals 3.25. And meters squared per second squared divided by meters per second squared is the same as times second squared over meters. And it all cancels out to equal meters. So that's 3.25 meters, which equals x. Our units check out. It's a reasonable distance, and it's in the right direction. So we should be pretty confident that we've solved it. And in general, questions that use this equation are relatively easy to solve. It only has 4 variables, and it's all fairly simple. Signs don't matter. The only trick to watch out for is it can't have gone up and past its peak. If we had looked for it going up and then coming down to 6 meters per second in this direction, we would have gotten a nonsensical answer because we're squaring it. So the equation can't tell the difference between a positive value over here and a negative value over there. But as long as you're on the same side of the curve, it's both going up or both going down, this equation works just fine, and you should be able to use it to solve a lot of your problems very easily.